Okay. Got the main gist? What's going on in this article?
Jeb Bush is an idiot.
Pretty much says that, doesn't it? It pretty much says that. Then, listen to the inflammatory language, right? Governor Jeb Bush and the legislature decided that courting brain damage ought to be a matter of quote-unquote personal freedom. It's not like this is unbiased. They're trying to demonstrate, using strong language, that this was a bad idea, and then they supply facts later on. They say that in 2009, 402 motorcycle-related deaths occurred here, and they say the number of deaths has grown in record numbers from 99 to 2009. So obviously you could assume that it was less than 402 back in 99, and it's grown ever since then to get to 2009. Michael?
Just to state it as a motorcycle rider.
Yes.
The only thing a helmet does for you is protect against the grinding or impacts at below 25 or so miles an hour.
Really?
Because if you get into an impact at 50, you're dead. It's
Okay. With or without a helmet?
With or without a helmet, it doesn't matter. I've seen those accidents, and it'll literally crush your head right into your chest.
Okay.
It's yeah, it's tough.
That's visual.
You're welcome.
Hello, Clipboard. I'll see you soon. No, but that's totally fine. I don't even want to worry about that. I don't want to worry about logistics of the accidents. I just want to look at the data they gave me and the data I was able to find. So, what I'm doing here is I've created a statistic called the Florida Motorcycle Death Rate, otherwise known as the FMDR. Florida Motorcycle or Motorbike Death Rate. I want to see if it's possible to support the claim that is implied in this article. What is the implication in this article? That it has gone up. That's the implication, isn't it? Jeb Bush should have never done this because people are dying in record numbers now, ever since they pulled the motorcycle ban away. So the implication is that the Florida motorcycle death rate in 2009 is going to be higher than it was in 99, which was, yep. Okay, in 1999 it was 0.00745. That's what it was in 99. What is it now?
Greater than.
Greater than. That's the key. Do you see how you pulled that greater than sign, friends? I'm not interested in knowing how much greater, just to see if I could even support this. Going back to what Ashley asked about 25 minutes ago, if I can support their claim, I might be interested in going back in and seeing if I can see how much greater it is. But I want to, before I even start, just see if I can support it. Do I even believe the claim from the paper that it's gone up in record numbers? Is that fair? Good so far? Good. Very good, very good, very good. So here's my curve. Here's my curve. Here's my null curve. I haven't filled anything in yet. I haven't filled anything in yet because I want you guys to fill in with me. There's a zero in the middle, as there always is. What is that zero contextually? Good. It's a 0.07%. Okay, very, very small. But we're claiming that it went up. So in order for it to be significantly higher, when we turn this data, we have 402 deaths out of 590,000-ish motorbikes registered. Where is that going to have to be in order for us to believe that? Where is it going to have to be in order for us to believe this? You guys tell me where to stop. Just tell me to stop. Stop here. Okay, I don't, Susie already said she doesn't know where, but we do know something about where. What is going to have to be here? How much? 5%, correct? Why is this just 5? It goes almost against what Mary's talking about, 2.5%. Why is it 5 now?
One tail.
One tail test. All the 95% confidence is on this side. So you still have 5%, it's all about the 5% area. But when you have a two-tail test, you split the 5% on both sides, 2.5, 2.5. With a single tail, you put all the area in one side. Zoe asked me that question.
Do we know that because of the sign?
Yes!
Okay.
That tells you which tail. And now, and if you, as long as you get the sign right. Say that again, Jared.
No, I got it.
You got it.
Because they're saying it's going up, not that it's changing.
Right! They're not saying it's changing. The implication from this article is that it's going up. Not that it's changing, but that it's going up. Is that fair?
No, because it's going only one direction.
Yes. Because it's only going up. Not that it's just different than it was in 99, but it's actually higher than it was in 99. Is that fair? You guys buy that? Zoe, you buy that logic?
Yeah.
Good. Please, Carrie.
So for the left, then it'd be on the other
Yes, if we were trying to show that it's gone down, we look at the other tail and show that it got too far left of 0. Very nice, my friends. All about standard deviations. FYI, I believe this number is like 1.645. That's not important to know. The TI will tell us if it's far enough by looking at this number right here. That number will tell us. If it's less than 5%, it means we got far enough over here to believe that the rate is going up. Okay, that's the, so let's find out. Let's find out. The TI will tell us. The TI will tell us. All right, so let's see. Let's see. Stat tests, one prop Z test. Oh, I went right by it. There it is. Okay, so fill in what we got. 000475. Make sure we're looking at this correctly. 0745. Thank you. And the thing I love about this one is these numbers are so small, it's hard to process the relative magnitude of p hat versus that p. That's where technology really shines. 402 out of 590,000, it's like, that's a tiny number, but so's that. So it's like measuring tininess. It's tricky. It's tricky. That's where technology really helps us. It puts it all in the same curve for us. Okay, so we got 402 out of 490,000. That's the right number for zeros.
590,000.
You have it.
Yeah,
That's it, right? 500,000?
Yeah.
Oh, I said it wrong. Oh. Do as I type. Sorry. And we're trying to see if it's greater than, right?
Yeah.
So if we have any area, it's going to be on that side over there. It's going to be on that side over there, right? Here we go. Let's draw.
Well, I didn't shake mine. Bummer.
Okay. Yeah. Well, go ahead. We getting similar results. Jared, go ahead.
I guess maybe I'm way off. Why can't I still use one prop Z int?
Let me come back to that.
Okay.
Can I come back to that? Let me come. I want to re-answer.
We're all really comfortable with
No.
it, and you can figure it out, right?
Because I got two good answers for
Okay.
you. I got two really good answers. One of which is actually kind of lame,
Okay.
and one of which mathematically is actually, I'm going to reiterate it from before.
Okay.
Hang tight.
5.
First of all, we all getting similar results.
Yeah.
You got a z-score of negative 1.79?
Yeah.
Okay, we got a p-value of 96%. Okay, now first of all, that's negative, correct? That's negative.
Oh.
Now one thing it won't show you, right, good, let's turn this off. We know that this was negative 1.79. P-value was about 96%. We'll come back to this momentarily. Where did our data land?
All over.
Well, all over where?
Yeah.
Careful. Was it in this 5%?
No.
No. Remember, we were trying to see if. It increased. But where did our data land? The data landed here and then shaded all. It's gone. The shade. I see what you're saying, Zoe. Let me address that question. The shade is going to shade to whatever direction the sign is pointing, regardless of where the test statistic lands. So if it lands way on this side, it's going to shade all the way into that right tail because that's what you told it to do. You've almost shaded the entire curve, right? Which means where did you land? Are you in the tank?
Oh, yeah.
Yeah.
Oh yeah, you're comfortably in the tank. As a matter of fact, we'll come back to that momentarily. You landed here, okay? So, can we believe this? Can we believe that it's increased? No, because we're in the tank, right? We're in the tank. We have to believe this. But we'll come back to that momentarily too. So, first of all, time out. I've got a Peirce circle from the last problem. Is that correct?
No.
That is not correct. It does not appear that the Florida motorcycle death rate has increased. It does not appear. That's what we were testing, correct? Zoe, I understand your concern. I totally get it. Because all that shade, the shade went all the way into the tail, didn't it? It picked up the tail, but it also picked up a chunk of the tank. If you pick up any bit of the tank, you're in the interval. Or you potentially could be in the interval, which means it's inconclusive. Which means we can't support the claim that the death rate went up. Ask me that question, Bob.
So it appears that actually death rate went down.
That's an alternative test that we could run, couldn't we? Hold that thought. Give me 2 minutes. We'll come back to that. So, just start with the claim. We were trying to support the newspaper by saying people are dying more. Does this support that claim?
No.
No, it says people are not dying more. That's all we're testing. We were trying to see if the paper's claim was legit, that people are dying at a higher frequency. We cannot support that claim. It's a failed to reject, so to speak, if you want to call it that. Could we be wrong?
Yeah.
People could still be dying more and we missed it?
Yeah.
What kind of error is that?
Type 2.
Careful, that's type 2, that's a false negative. It's a negative, right? Because we said nothing changed. That's a negative test result. Excuse me. We could be wrong. What's the chance of it? Trick question, what's the chance of it?
We do not know.
We do not know. Kara, what did you say last time?
Beta.
Beta, good, beta. We haven't calculated it yet, we'll learn it soon enough. It's a type 2 potential. It's a type 2 potential error. Go ahead, Susie.
So if we actually proved they were right, basically would be 5%.
Or less than 5, right? Now, I want to get back to something that Bob said. I haven't forgotten your question, Joe. I'm coming back to it, I promise. I'm coming back to it, I promise. Bob said something. He said, this data actually doesn't only, this is going to sound a little weird, it doesn't only not show that it's increased, but it does show that it has decreased, doesn't it? It shows that it's decreased. You see how? Take a look. We'll look at it mathematically first, then we'll run the test again. Check it out, check it out. Now we know that the tank for increased Florida motorcycle death rate
Just went to sleep.
went to sleep. The tank ended over here. In order for us to believe it increased, we'd have to be in this 5% outside the tank over there. Fair enough? Fair enough. Let's look at an alternative question. Suppose we were trying to not only disprove the paper's claim, but prove that the rate has gone down. The tank would then be turned around, and there'd be a line over here somewhere with 5% this way. In other words, it would be a left-tailed test, wouldn't it? It would be a left-tailed test. And this tank over here would show the rates are the same or they're increasing. And this tank over here, the separate tank that Michael mentioned before, would be the decreased death rate. How can I tell I'm in the decreased tank? By virtue of that number right there. I know I'm in that tank by looking at that number. The complement of 96.34% is 3.7%. If I was to run this test the other way with a left tail, it would look exactly like this, but like that.
Less than 5%.
It would be less than 5% on this side. So you could actually combat this and say, not only have I shown that it hasn't increased, we've shown that it has decreased. Yeah, I believe that more people died in 09 than in 99. I'm not contesting that. But what else is true about 09 versus 99?
Population increase.
There are a hell of a lot more registered bikers in 09 than 99. So yeah, more died, but fewer as a percentage died.
And it doesn't say that less people had helmets on.
We never tested the variable of death by with or without helmet. We never even looked at that. But they're trying to use that very bland data to prove that, right, Bob?
Because the legislature doesn't say you have to be an idiot if you're riding a motorcycle. It just says you have the option to be an idiot.
That's right. Now let's be careful with our biased words, Bob. Use your nice words.
I ride it without a helmet when I lived in Florida, but
You
that
see,
was my personal choice.
the idea is, this is such a lame claim. This is such a lame claim. Careful. This is such a lame, careful. A lot of anti-Florida sentiment going on right now. Are we still smart as the 2000 election? Come on, folks. All right, now, watch this. I want to answer Jared's question. I want to re-answer Ashley's question now. Why can't we just use a one prop Z in and call it good, right? Why can't we just use a one prop Z in and call it good? So let's do that. Let's do a one prop Z in. Same data, right? Still 402 out of 590,000. Still 402 out of 590,000. Okay. And we run a calculation. And we get that the confidence interval is 0.00061 to 0.000. I have one too many zeros, one too few zeros there. No, 0.00061. That's it. 0.00061 to 0.00075. Right? The problem is, this disagrees with the hypothesis test. Right? If you're trying to show that it decreased, it doesn't show the decrease here. It's actually, the 0.000745 is actually in that interval. So in other words, it does help us do ours. It shows that it does not appear that it increased. But this doesn't show that it decreased. Do you remember why I told Ashley we don't use the confidence intervals for single-tailed tests?
But
Hold that thought. It's a mathematical question, not a statistical. It's more mathematical. Confidence intervals have two sides. These tests sometimes have one, which means the cutoff values on the confidence interval do not fall perfectly in line with these because of where the 5% is. A two-tailed test, 2.5, 2.5. When you have a one-tailed test, you have to shove it down and adjust this. And this is one of those cool little cases where you get conflicting results if you run a two-tailed versus one-tailed. It's close enough on this side. Remember how the p-value for the opposing one was 3.7%? That's close enough to 2.5, but still on one side of 5, it traps between that gray area. That's why, because we don't get 100% agreement with it.
But the question, it doesn't ask if it lowers. We're asking the question if it raises, which...
Totally,
Right?
totally. But the problem is you can't even claim that you've attracted. You can't claim that this does that 100% accurately because you've given it a top and a bottom value, not just a top. I love what you're saying, Jared. And I'm not saying I disagree with you in theory. I wish we had one-sided confidence intervals. I would throw out the entire back part of this course and do everything with confidence intervals because you said perfectly, you're used to them. You are used to them. Yes, the world, for whatever reason, likes us to use these when we go one side. I don't have a good answer for you. I'm not a trained statistician. I got no good answer. I agree with you. If we did one-sided versus two-sided intervals, this would take us into week 10 and we'd be perfectly happy. I'm with you, brother. I'm with you. It's just the world doesn't work that way, unfortunately. That's a crappy answer, but not being a trained statistician, I got no better one. Is that fair enough?
Yep.
I mean, it's crap.
Just like when I look at that, it's the point 0.075
Right.
is so close.
Oh,
that-
I know, but so close is hard to measure. That's why we talk about significant.
But it's
Statistically significantly, it's in the interval.
Yeah.
It's in the interval. The problem is, if we were trying to show the opposite, we'd have to be out of this interval, which we would be in a single-tailed test, but we wouldn't be in a two-tailed interval. That's the problem. Sometimes you get this conflict. And that's, I feel you. I totally feel you. Confidence intervals are so intuitive. Why go to this? Because this is how one-tailed ones are set up. That's the best answer I've got. It's not a good one, Susie.
So basically, for a one-tailed test, you want to use one prop Z test, and for a two-tailed.
You have a choice. You do have a choice for a two-tailed test, but just whenever I ask you to do a hypothesis test, just always use the one prop Z test and just use the does not equal sign.
Okay.
Is that fair? You see what I'm getting at there? You have the option, of course, like Ashley said, and Jared has reiterated, to run the one prop Z. By all means, do that. If you choose to do that on the exam, just tell me that's what you're doing. Full credit, of course, because it's the same conclusion. You'll get the same conclusion as long as it's a two-tailed test. You might or might not get the same conclusion with a one-tailed test, as we just saw. It's a great question. Thank you, Ashley and Jared, for that. It's a great question. And the best answer is, let's just learn how to do one-tailed confidence intervals. But nobody does it for whatever reason. This is like the mathematician going, why not? That's so logical. And the statistician's like, no, it's quite wrong. We don't do it that way. Okay, well then we'll just do this, I guess. Fair? Mike, we had a question, I think.
Well, I just had a statement, really. When you're looking at this in the confidence interval at
Yes.
this point, the data does exist within, so you could say that, I mean,
You can't prove it going either way, up or down.
well, right, but at that point, you don't have to because it's within it.
Because you disproved the original claim, which is that it went up totally. But my point is, if we wanted to turn it around and say we actually think it's going down, this doesn't support that claim. Because it's still within it.
Okay.
But if you could set this thing up one-sided, let's it turned off. What would then happen if you could set it up one-sided is the whole thing would shift to the right, and the value 0.000745 would be out of it on this side. You're right, because these are very small, close together numbers. But if you could shove this interval to the right, the 0.000745 would actually be out of the tank on this side, and you would actually support the claim we just made, the secondary claim, which was not only did it not go up, it went down. That interval does support the claim that it didn't go up, but it doesn't support the claim that it went down.
So it's the difference between showing why your claim is stupid and
You
then...
guys keep using the word stupid. Making me nervous. You keep using this word. I don't know
No,
if it means
it's
it's
the
a mix.
difference between saying your claim's wrong and showing you why you're dumb.
I am not going to answer that question until your tone improves, mister. It basically is... I like this tone in this class this morning. Basically, what you're trying to do is you're trying to statistically support your claim with a margin of error backed it up. The question is, you have to develop the correct margin of error. A two-sided error will never be able to show you increase or decrease because it's only showing change. You have to set it up to show an increase or decrease, and that's where the hypothesis test kind of steps in. Is that fair, Jared?
No, I get it.
I don't like your tone. Go ahead, Michael.
Just to ask the, I mean,
Mhm.
most of the data shows going to the left. I mean, if you're looking at most. of the
Define
data-
most.
Well, if
You're
looking at-
pretending there's symmetry that might not be there.
Okay, gotcha.
You know, I love what you're saying, Michael.
You know what I'm
But you
saying?
see, that's the whole point though. If we adjust that thing and make it one-sided, it'll all go to the left. That's the whole point. You're saying the correct thing, brother.
Okay.
You're saying the correct thing. It's just that we have to make sure we 100% do it correctly. And I don't mean 100% confidence. I mean 100% agreement with the one side. Yeah, you got it, man. You got it. It's all, you guys are saying the correct things. What you're struggling with, understandably, actually, you're struggling understandably with the fact that this is not as concrete as 243 was, but you're making the connection. You are. You're making the connection. That's why I like taking our time through this.
Fine. I'm answering the question you asked.
Yes. No,
Bring it up.
Absolutely, absolutely, absolutely. You got that, Jared. But I love the fact that the question that we weren't asking actually answers your
right.
secondary question. Jamie, go ahead.
So we failed to reject the null.
Yes, correct. That would be, if you're going with formal language,
Yeah.
you got a big p-value, that's a fail to reject the null. Love it. Good?
Yeah, just bring it back around.
That's good. That's totally fine.
Being smart.
Good. Being connected and cohesive. E-smart. I like that. Very good.
I'm just using opposite.
That's okay. As long as you stop saying stupid and dumb and things like that. All right, friends, you ready? I got one last data set for us to play with as far as proportions go. You might remember this.
Oh, yeah.
You might remember this. Okay? This was, if you had me in 243, you saw this about 10 weeks ago. Actually, more than that, about 15 weeks ago now. If you didn't, there was a series done by a group called Granda Reportagem that had a series of country maps. And they used the percentages of color on the map to indicate certain percentages that existed in the populations. This was the U.S. circa, I want to say, 2003, 2004. The claim is that the red percentage showed those that were in favor of the war in Iraq, the white percentage were against the war, and the blue percentage couldn't find Iraq on a map. Okay? So, here's what I want from you guys. Smartphones, computers, away. Smartphones, computers, away. Here's a world map. Take one. Hand them around. Smartphones, computers, away. Smartphones, computers, away. Smartphones, computers, away. Smartphones, computers, away. No, no lifelines. No lifelines. Will you mute this down?
Okay, well, I still remember doing this in the fifth grade.
All right, let me clear up the board here. You need more? You guys good? You need more? Okay.
All you have to do is search the middle of the map because there's been a complete war there since the beginning of time. I don't even know why we're there.
Okay, first of all, I want us all, try not to write on it, because what I'm going to have you guys do is, I'm going to have you guys take this home over the weekend and ask as many people as you can and see if your friends and neighbors and stuff can find it. And we'll recollate the data on Monday, or whatever I say again, Tuesday. So first of all, find Iraq. Put your finger on, don't help your neighbor. Testing individuals
We
here.
don't live anywhere. near
Don't
it.
help your neighbor. Don't, Richard, stop it. We are going to do statistics for pure discovery's sake right now. We're going to collect the data first. Now this, I'm going to caveat this by saying this is not how your exams work. In your exams, I give you the claim I want you to test, and then you use the data to test it. Here, we're going to collect our data first. We're going to collect our data first, and then form a hypothesis based on that. How's that sound? This is discovery statistics versus, if you will, proving statistics. So, you got Iraq? You got Iraq marked? Okay, you got Iraq marked? Okay.
More or less.
Well, no, one Iraq.
Boston is.
Because I'm testing this. I'm testing this. Okay, so now,
I'm pretty sure we're in the blue group.
who wants to come show us Iraq on this map? Be brave.
Ashley knows.
Be brave. Ashley knows? Which Ashley? I got 5 Ashley.
This one right here.
Go find Iraq. Richard, you know. Get up there.
I don't know.
You were just commanding everybody. Where is Iraq, my friend?
General area.
Where is Iraq?
I know
Where's
where Iran is.
You don't know that.
There we go. You go, my friend. Use the laser. There we go. Let's find Iraq.
I believe I know which one it is.
The yellow button.
Oh, there we go.
Let's find her. Let's find her.
Oh, hell, I
That's
can't-
Australia.
I can't see the laser. I can't see the laser.
Oh, you get the laser. Gotcha, gotcha. Who wants it? What the hell is
It's
that?
above Saudi Arabia and
Good.
Iran.
It's right there, yeah.
Yeah.
Right there, Fred. Okay. Now, I am not being judgmental if you could or couldn't find it. I am simply a statistician.
Okay, what word? I can't, let's see what the lines are. I think I see it.
Yeah?
Yeah.
I'm not being judgmental, simply want data.
Okay.
I simply want data.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. I got n equals 36 today. Okay, I'm going to shut this down. I was counting the sample size. We have a sample of 36. Hardly random sample, but what the hell, good enough. So I got sample size 36. X equals number of us that actually found Iraq. Let's see hands. Number that found Iraq. 1, 2, 3.